Hello everyone. Welcome to Machine Learning Made Easy, a business application based tutorial in R using the H2O platform. Before we begin the tutorial, let me introduce myself. My name is Aditya Ganesh and I hold a postgraduate diploma in management in human resources from XLRI Jamshedpur and degree in chemical engineering from NIT Allahabad. Before we get into the tutorial, I would like to clarify why I'm making this video. I was introduced to machine learning a couple of years ago, partly due to my academics and partly due to my personal interest. And I've come to realize that in the very near future, every manager is going to have to know how to implement machine learning or at least leverage machine learning in all his decision making processes. Now, this brings to question, do you need to be an expert? Do you need to be a data scientist to be able to implement machine learning? And the short answer to that is no. With the availability of a lot of open source resources, implementing machine learning has become extremely easy in today's day. What I'm going to be doing through this video is guide you through a hands-on approach and help you implement your own machine learning model with a very little code. So this brings me to the two kinds of audiences that I'm trying to address in this video. Firstly, for those who have no prior experience in machine learning or coding, I'm going to try to show you how simple it is to implement your machine learning model. I obviously recommend that after watching this video, you go back and understand the concepts of machine learning and the basics of programming. But as a start to get a feel of what you can expect out of machine learning, this is going to be a very useful video. And for those who already have experience in machine learning and coding, I want to introduce the concept of automated machine learning using the H2O platform. This platform and the concept of automated machine learning is quite useful and helps improve the efficiency of any manager who's using machine learning. So firstly, let's try to understand what our project is going to be. The project is going to be predicting employee turnover, or basically predicting which employee in your organization is going to be leaving. The data set that we're going to be using is the IBM HR Analytics Employee Attrition and Performance dataset. It's available on the link that I've mentioned over here. For those of you who already know the basics of machine learning, I recommend you skip ahead and go to the actual hands-on part of this tutorial. And for those of you who don't, we're going to briefly understand what machine learning is and then move on to the practical part of this tutorial. So machine learning is basically an application of artificial intelligence. It's not the whole of artificial intelligence, it's a subset where we teach the computer to recognize patterns in data by feeding it examples. So for example, if you have a data set, you can split it into something known as a training set and a test set or a validation set. You feed the data in the training set to the computer. Through various algorithms, the computer learns how to recognize patterns in the data and thus be able to predict a certain outcome, which is defined by the user. And then you feed it the test set or the validation set, and it predicts the outcome from what it understood from the training set. Because this data is something that you already had, we already know the actual outcomes, and thus we can verify how well the computer has been able to predict the outcomes on the test set. The example that I gave you is not something that is always done in practice. That's primarily because splitting the data into just one training and one test set makes it subject to a lot of bias based on what kind of data is sampled. In practice, what happens is we use something known as the k-fold validation technique, where the data set is split into k different parts, and the each in each iteration the validation set is changed. So you run through k different validation sets and you average the performance of the machine learning model to get your output. Now, the kind of problem that we are going to be dealing with today is something known as a classification problem, where we use machine learning to assign a label to an entry of data. The most commonly cited example is how your email classifies spam. Uh, the email provider goes through the text of your emails, and based on what it understands, it sends some mails to your spam folder and sends the rest to your inbox. Other examples of classification is detecting fraudulent transactions on your credit card, predicting whether a customer is going to default on a loan. There are various other examples, but today we're going to be dealing with employee attrition. So in machine learning, we have three broad stages. The first stage is processing the data. We often have to change the data into a format which is easily understood by the computer and the machine learning models that we're going to be implementing. The second stage is actually generating various models to that can predict the data. And what happens during this model generation phase is that many of these models are subject to a lot of these hyperparameters, and we need to tune these hyperparameters to get the best possible result. And once we've tuned these hyperparameters to get the best possible results, we need to aggregate these models and create something known as an ensemble, which is the best of the best. It creates a combined machine learning model which takes the best parts of all the models and develops a robust model that can predict your data. Now, there are various kinds of classification algorithms, such as random forest, logistic regression, naive Bayes classification. Getting into the details of how these models work is beyond the scope of this tutorial, but I recommend that anyone watching this video just read up about these models, or if you are going to be taking up the basics of machine learning elsewhere, you will definitely come across these. Now, let's talk about automated machine learning. What exactly automated machine learning does? So, automated machine learning takes in data sets, metrics, and constraints from the user, runs these through as many algorithms as it possibly can, and then assembles the best possible machine learning model as the output. And as you can see, this saves a lot of time and a lot of technicalities that are involved in trying to tune and assemble your own machine learning model. And all of this is done through a system, and this is specifically useful for managers as they don't really need to get into the nitty-gritties of how different algorithms work. Let's get started with actually building a machine learning model and using it to solve the problem statement of our project. The first thing that you're going to require is to download RStudio. I'll include a link in the description that will help you through this process. Once you've done that, turn on RStudio and click on File, New File, and click on RScript. Once that opens up, it should open up a window on the top left hand side like this. You can name it whatever you want, and below you'll see something known as a console, which is where the output of the code that you're running will be displayed. Once you've got this, let's get started. So the first thing that we're going to be using is the H2O package or the H2O library. A library is basically a collection of various functions that makes it easy for the user to call and implement. So click on tools, click on install packages, and if you type H2O, this is the first thing that you get. H2O is the package that we're going to be installing. I have already installed this, so please go ahead and install it. Once you've done that, you will see this blue arrow mark, which shows that the code has been executed. And when you see a blue arrow mark, you can start. Let's start typing our code. So I'll include the code in the description, a link to the code in the description, and I'll be copy pasting the code so that you don't have to see me actually type this out. You can follow this at your own pace. So the first two lines of code that I'm going to be executing, you can highlight them and then click on run. And once they've both run, you can see this blue arrow mark that comes at the bottom showing that they've completed execution. Basically what I'm doing over here is I'm calling the H2O package and initializing it. The next step of the process is actually loading the data. In these two lines of code, first I'm initializing a variable called IBM_data and reading an Excel file, specifically a CSV file that is located at this path into it. And I'm also telling it that the header, basically that the first row of the data in the Excel file refers to the column headers. So let's run this line. And then the second line of the code is basically asking the computer to give us an output of the structure of this particular data set. And if we run it, you basically get a list of all these things. And if you go up, you see that this is a data frame consisting of 1470 observations with 35 variables. These variables refer to each of the columns. If you notice, the first column age actually has some sort of a precursor of one dot dot age. This seems to be a bug which created a lot of issues for me. So if you see this, please execute this line of code. This slide basically is renaming the first column to age. Run the previous line of code again just to see if the change has been implemented, and if you see, yes, the first column is now just age. And now that we've loaded the data, we can get on to actually cleaning the data and making it useful for us. So before we clean the data, let's try to understand the data, and I'll be doing that through Excel because it's a lot more convenient. So here you can see that we have a lot of columns with a lot of different kinds of data in it. The first column is age, then we have quit, and so on and so forth. The second column, for most of you, if you have downloaded this data set directly from the link that I gave you, might be attrition. I changed this to quit for my own reasons, so you might as well do that. So let's try to understand what the column quit basically is. So quit is the column that we are trying to predict. It tells us whether an employee has left the organization or not, and this is the what we're trying to predict. Further, we have columns such as business travel, daily rate, department, distance from home, etc. And each of these columns contain different kinds of data sets. What we're going to be doing is, firstly, let's look at a column like employee count. Employee count is basically one for everyone, and this basically means that this is just counting the number of employees. And similarly, employee number contains a unique number that's assigned to each of the employees. Columns such as these will not impact our machine learning model because they have no direct relevance to whether a person is quitting or not. Similarly, if we look at a column like overtime, over 18, we can see that it's yes for everyone, basically saying that all employees are over the age of 18. And again, because it's the same for everyone, this will not be impacting a machine learning model, and hence they can be deleted. So you can go ahead and run these 5 lines of code. What it's basically doing is I'm saying that in the IBM data set, in for the column education field, set it to null or basically deleted. And I'm doing that for 5 different columns. Let me just warn you that the lines of code for this part where I'm cleaning the data might seem a little daunting, but they're quite straightforward lines of code that are repeated over and over again. The next type of cleaning that we're going to be doing is something known as normalization. If we look at a column such as distance from home, we can see that the range of values are between 1 and maybe 27 or so on. It's these numbers are basically kilometers and they range in the tens. Whereas if we look at something like monthly rate, we can see that these go into the tens of thousands, and numerically their magnitude is a lot more than distance from home. When the machine learning model gets an input of all this data, simply because of the magnitude, it is possible that it will give a lot more importance to the column monthly rate rather than distance from home, just because of the magnitude. And this is something that we want to avoid. And the way we deal with this kind of problem is through normalization. What we are going to be doing is something known as min-max normalization. Basically, I'm defining a function saying that subtract from a particular row value x the minimum value that exists in that column and divided by the difference between the maximum and minimum of that particular column. This basically results in a modified data which recategorizes all the data into a range between 0 and 1, thus keeping our the variation in the data intact, but ensuring that all columns that fall under this issue will remain within the range of 0 and 1 and not create an unfair impact on the machine learning model. I am now implementing this function for various columns that we have, and let's just execute all these lines of code. Now that that's done, let's look at another kind of issue that we have in our data. The column business travel contains 3 values: non-travel, travel frequently, travel rarely. We know that in this column the data cannot take any form except these 3. Similarly, if we look at something like job involvement, though it's a numerical data, we see that it takes up values of only 1, 2, 3, or 4. This implies that this data is collected from a survey which the employee filled, and it can exist only in these 4 values. There are no intermediate values that this can take up, which brings us to categorical variables. Categorical variables are discrete values, and machine learning models cannot understand string values such as travel rarely or travel frequently. And it also needs to understand that job involvement is not a continuous variable which can take up any value between 1 and 4, but rather only 4 different values: 1, 2, 3, and 4. So what we're going to be doing is converting these particular columns into categorical variables. I've copy pasted the code, and if you look at the first line, basically what we're saying is that the column gender in the IBM data is basically the column gender converted into a factor. As dot factor is the function used to convert variables into categorical variables in R. So let's just execute it and look at the final resulting structure of the data. And as you can see, we now have a modified data set. For example, quit is a factor with two levels, no and yes. Business travel is a factor with three levels, non-travel, travel frequently, and travel rarely. Our daily rate is now a value between 0 and 1. And so we can see that our data is now ready for us to now implement a machine learning model. Uh, the first step in using H2O to develop machine learning models is to convert the data frame that we had, IBM data, into an H2O data frame. This can be easily done by using the function as.h2o. I have called the variable with the H2O data frame clean data. So we can go ahead and run this. Once the line of code is executed, let's look at what we're doing next. So first I'm defining y as a variable which contains quit, or basically the output that I want. And next I am defining x as all the columns apart from y. So basically x contains the names of all the predictor variables, that is all the columns apart from y, and y is my outcome variable quit. Let's just run these two lines of code. The next part is where we are going to be using automated machine learning. This is the syntax for this code. What we're saying is h2o.automl is going to result in a model called AL, which I've defined. Y is equal to y, basically the output is going to be quit. X is going to contain all the other predictor variables. The data frame that I'm going to be using to train the data is clean data. As I mentioned earlier, we follow something known as k-fold validation, and AutoML in H2O has a default of n folds. As you can see, if you leave your cursor on top of the H2O.AutoML, you can see that n folds is set as 5. I'm setting the max runtime as 500 seconds. Feel free to make it anything else. Seed is something that is used as a stochastic parameter. You can set it as anything you want. I recommend you set it as 1 so that both you and I get the same results. And balance classes is something that I'd like to explain. If we look at our quit column and just click on only the yeses, you can see there are 237 out of 1470 that are yes, people who have quit. But this is quite small compared to the number of no's. By setting balance classes to true, we are ensuring that the data that is taken for training, there is the correct proportion of yeses and nos in the data, rather than maybe sampling a data that contains only no's or only yeses. So once you've done this, let's just execute all these lines of code to develop the model. While the code is running, there will be a percentage symbol to your right side. Once this reaches 100, we'll know that the code has been executed. Hopefully by now your model has been executed. You will see this 100% sign towards your right side in the console. You can ignore these warnings that are marked in the red. As long as there is no error message, you're fine. So there you have it. With these simple few lines of code, you've actually built a machine learning model. Now we really need to see how well this is working, and for that we're going to be testing the different performance parameters of these models. Uh, in H2O, the automated machine learning stores the best models in something known as the leaderboard. So I'm going to be calling that. So naming the leaderboard LB, and you can call it by saying AL, which is our automated machine learning model, at the rate of leaderboard, and I'm going to be printing it. So let's just see what this gives us. And yes, there you have it. Now we have these models that are the top of our leaderboard. And as you can see, they have the model ID, which tells us what is the name and algorithm used in the model, as well as something known as AUC, which is area under the curve. The area under the curve tells us what is the probability of the model making an accurate prediction. And the closer this is to 1, that means the model makes 100% accurate predictions, whereas at 0 it makes no accurate predictions. And we can see that the best model, according to the automated machine learning leaderboard, has an AUC of 83.6%, which is quite good. So let's actually look at what the leader of a model is, and we can just call that out by saying AL at the rate of leader and running this line. And let's look at this. So we have a lot of details about the models that are presented, and here we have the model ID is tagged ensemble best of family AutoML. A stacked ensemble is basically a class of algorithms that that are also known as super learners that collect the best parts of all the models that are generated and aggregates them together to give us an overall model. And as you can see, there is a confusion matrix that is provided for our AutoML, and those of you who know what a confusion matrix is, you will understand the importance of this. And for those of you who don't know what a confusion matrix is, please read up about it, because it's a very important part of our of machine learning. So on the five-fold cross-validated data set, we can see this is the confusion matrix, and this is the AUC result, which we saw earlier, 83.6%. Now, so this means that our model is quite good and can predict accurate results 83% of the time. Let's also, there's another interesting fact that we can learn from these models, uh, but we cannot use this on a stacked ensemble. So what we'll be doing is seeing which model, the first model that is not a stacked ensemble. So as you can see, as printed earlier in the leaderboard, the best model is the stacked ensemble. Next we have the GLM. So this is the first non-stacked ensemble model, and we're going to look at this. So with this line of code, what I'm doing is I am calling the second model from the leaderboard, which is basically the GLM. In case your GLM or any other model is not in the second position, but rather third or fourth or whatever. So look for the first model that's not a stacked ensemble. Look at its uh, index and enter the number over here. So I have entered 2. In case you find your GLM model in the third or fourth position, please enter 3 or 4 respectively to get that particular model. So I'm running this line of code, which is getting the GLM model. And what I'm going to be doing is get something known as a variable importance plot. Now, if you run this code, you will see on your right hand side there is a plot which tells us what are the important variables, the top important variables in this model. And if you look at it, overtime seems to have the most importance in predicting whether an employee is leaving the organization or not, be it whether they have overtime or not. Further, we can see that travel is another factor that seems to be impacting whether employees leave or not. And the other variables, if you look at it, such as job involvement, work life balance, job satisfaction, environment satisfaction, seem to be data from our employee engagement or employee in satisfaction surveys, which implies that ensuring your employees are engaged and satisfied is quite important to ensure that they don't leave your organization. Uh, what I want to do right now is try to show you why the AutoML is much better than any other machine learning algorithms that you could implement on your own. So what I'm going to be doing right now is I'm going to create a random forest algorithm to and create the model and see what output I get out of that. Uh, as you can see, the variables are pretty much the same, except that I'm defining n folds as equal to 5 because uh, this is what was the default for our AutoML, and I'm setting the runtime as 300 seconds. Let's look at what output we get out of this. So I'm running the code, and once the model is built, see, it's dropping a column called job role because it says that it's not important to the model. Anyway, let's just run ML and see what happens. And we get a lot of data, and let's look at the cross-validated metrics. And you can see the AUC is only 78.7%, which is quite worse than the model that we generated. Okay, let's just see if this works for other models. And what I'm going to do is I'm going to use the gradient boosted gradient boosting machines, GBM, and let's run the same set of code again. So GBM is another form of algorithms. Please read up about this if you're interested. And yes, we have the output for that. And let's look at the cross-validated scores again. And the AUC is only at 79.56%. And this shows that the GBM is still not able to perform as well as our automated machine learning model, the stacked ensemble model. I'm just going to run this through another algorithm and let's see what happens. So I'm looking at deep learning as the algorithm that I'm going to be using. This may take a little longer to run than the previous two algorithms. Now that it's run, let's just look at the AUC score, and here you can see that the cross-validated score of the deep learning model is actually quite higher than the previous two algorithms. It's at 82%, a little less than our stacked ensemble, but quite close. Uh, this shows that our stacked ensemble is able to get the best of all the algorithms that it processes and give us the best possible model there is. Just to look at the variable importance that the deep learning model has considered, we'll just run that. So just change this code to variable importance at ML. And there you have it. So we have another graph, and you can see that while overtime and business travel are still important, we can see that environment satisfaction, relationship satisfaction, and job satisfaction continue to exist in this model as well, which further highlights the fact that employee engagement and satisfaction probably have a lot to do with whether an employee stays with the organization or not. So that pretty much covers everything that I wanted to share in this video. Uh, Let me just recap what we did. We cleaned our data, we used normalization techniques, converted variables into categorical variables, developed a automated machine learning model, and looked at its leaderboard using the H2O platform. And then we looked at what are the performance parameters that it displayed, as well as compared it to some other mainstream machine learning models. So, through this process, what we've understood is that we can use machine learning to give us a lot of input and help us make decisions. However, this video was only the beginning. This was mainly to give you a feel of what can be. In subsequent videos, I'm going to be talking about how to improve the performance of these models, how what are the ways in which we can modify our data to give better results, and ultimately be able to make decisions, and how do we make decisions using the predictions of these models. So for those of you who've never used machine learning before and this was the first time you tried it out, I suggest that you try to understand the basics and improve your conceptual clarity regarding machine learning. And for those of you who have some experience, the best way to is to practice. I am no expert, and I'm trying to learn by playing with data sets that are available freely on the internet. And I think that's the best way to learn. This was my first video of such a kind, and I would love to hear your feedback and how I can improve this. I hope this was a good learning experience for all of you. Thank you very much for